All right, welcome Math 10C students. Today we're going to be working on lesson 7.4, which is all about using substitution strategies to solve for a system of linear equations. So one algebraic strategy, of course algebraic working it out manually rather than typing it into the calculator, is to solve by substitution. So in this, we're going to be substituting in an equation for a value. So when we use this strategy, it's effective when we have one of our variables that has a coefficient of 1. Okay, so we can really only effectively use this strategy when we have a variable that has a coefficient of 1. So let's take a look at the example below. It asks us to solve this linear system. So we have two equations here. We have 2x plus y equals 3, and we have 4x plus 3y equals 5. So I'm just going to rewrite these on some paper so that you can see the process and we can work through it together. We have 2x plus y equals 3. We'll call that equation 1. And then we have 4x plus 3y equals 5. We'll call that equation 2. So if we look at our two equations, which equation has one of our variables with a coefficient of 1? You probably said equation 1 because you can see here that y, there's only one y, so we don't write the coefficient once, but it has a coefficient of 1. So first thing that we need to do is we need to rearrange that equation to solve for y. So let's do that right here. We have y equals negative 2x, okay, because remember, if we want to get the y on its own, the opposite of adding 2x is subtract 2x plus 3, okay? So now what we're going to do that we have it in this form is we are going to substitute this equation in where the y value is, in our previous equation, or in our equation number 2. So let's try that in. We're going to substitute that entire value in where we have the y here. So we end up with 4x plus 3 times negative 2x plus 3 equals 5. Now remember the distributive property that we used all the way back in chapter 3 right at the beginning. So we still have 4x. Now the 3 is distributed to both of these terms. So we have 3 times negative 2x, which gives us negative 6x, and 3 times a positive 3, which gives us positive 9. Okay, and then we just need to finish our equation here. So combining like terms and then solve for x. We end up with negative 2x plus 9 equals 5. Negative 2x equals, now to get that 9 to the other side, we need to make that into a negative, so minus 9. Negative 2x equals negative 4. And divide both sides by negative 2. X is equal to 2. Okay, so that's the first part. We have solved for x. I know this one has a lot more work to it, so that's okay. It is a good system. It just is going to require you to show a little bit more work. So we now have the value of x equals 2. We're going to take that value of x equals 2 and substitute it into either of the two equations to get an answer for y. So let's just use the first one because it's much more simple. 2x plus y equals 3. That means 2 times 2 plus y equals 3. We have 4 plus y equals 3. In order to bring the 4 to the other side, I need to subtract. Y equals 3 minus 4. Y is equal to negative 1. Okay, so we have our y value as well. And then the last thing that sometimes they're going to ask you to do in these questions is to verify. So I'm going to use these two answers and substitute it into both of the equations to make sure that the left side equals the right side. So let's start with this first equation. 2x plus y equals 3. Sorry, can't see the work. Okay, so I'm going to substitute in these two values. That means 2 times 2 plus negative 1 equals 3. 2 times 2 is 4 plus -1. Okay, and then we end up with 3 equals 3. It works for that equation. Let's try the other equation. 4x plus 3y equals 5. Let's substitute in those values. 4 times 2 plus 3 times -1 equals 5. 4 times 2 is 8, plus 3 times -1 is -3, and 5 equals 5. So left side is correct, and right side is the same, sorry. So that means that my solution is x equals 2, y equals -1. So that is my final answer. That is the solution for my system of linear equations. So all of that work is done in the notes for you as well, but I wanted to see, for you to see the process of working through it so that you could try that on your own. So now I'm going to suggest that you try the check question. The check is on page 401. So try that check question on page 401 on your own. You can pause the video right now, and then you can unpause to watch me finish the solution for that question. So it asked us to solve this linear system. We have two equations. We are going to use this equation because you'll notice that the x has a coefficient of 1. So we're going to solve for x. X equals -3y minus 2. So anytime we have an x, we're going to substitute in -3 minus 2. So we're going to substitute that into equation number 2. So -3y minus 2 plus 5y equals 6. So remember, distributive property, you're going to distribute both of those terms. -3 times -3y ends up as a positive 9y, and -3 times -2 is positive 6, plus 5y equals 6. Let's rearrange those terms. We have 9y plus 5y is 14y. Okay, and then we can move the 6 to the other side. We end up with 6 minus 6. 14y equals 0. So that means y equals 0 because 0 divided by 14 is 0. So that means my y value here is 0. Now, in order to find the x value, I will substitute in y equals 0. And we'll just use equation number 1. Again, it doesn't matter which one in this case. X plus 3 times 0 equals -2. That means x is equal to -2. So x equals -2. So my solution is x equals -2, y equals 0. Let's make sure those values work in both of my linear equations. So I have -2 plus 3 times 0 equals -2. -2 plus 0 equals -2. So -2 equals -2. On the other side, -3 times -2 plus 5 times 0 equals 6. So -3 times -2 is 6, plus 0 equals 6, so 6 equals 6. So the left side and the right side are equal. That means I have verified, and x is equal to -2. Y is equal to 0. Oops, sorry about that. All right, so it did work. We are happy. We have verified. Good to go. Now, we're going to look at another example. In this example, we are going to be creating a linear system to model a situation. So this one I will also do on lined paper, just so I can walk you through the process. Okay, but I am doing the example that's on page 402. So let's work through that example on page 402 together. So this is the information that you have been given, and we're going to solve this problem. So it asks us to create a linear system. To model this situation. The tickets are sold for the senior safari day at the Greater Vancouver Zoo. Meryl buys 5 admission tickets and 3 train tickets. She pays $26. And Howard buys 2 admission tickets and 1 train ticket. He pays $25. So first thing we're going to do is we're going to make equations out of this. I'm going to say A is my admission, and T is equal to my train tickets. So the first equation, we have 5a plus 3t equals 65. And our second equation, we have 2a, so 2 admission tickets plus 1t, which is our train ticket, equals 25. So there's our two equations. We'll call them equation 1 and equation 2. All right, so if we take a look at these two equations, you'll see that equation 2 has a coefficient of 1 for the variable. So we're going to rearrange that equation to solve for t. That means t is equal to negative 2a plus 25. Okay, so I've rearranged it into a form that I can use. Now I'm going to substitute this equation into the t in equation number 1. So we have 5a plus 3 times negative 2a plus 25 equals 65. So let's solve it. 5a plus 3 times negative 2a is negative 6a, and 3 times 25 is a positive 75, so plus 75 equals 65. Let's combine like terms. We have negative a, and if I want to move the 75 to the other side, I need to subtract 65 minus 75. Negative a equals negative 10, and to get rid of that negative, divide both sides by negative 1, a equals 10. Okay, so I've solved for a. Now that I've solved for a, I can use this value of a and put it into either equation number 1 or 2 to solve for t. I'm going to use equation number 2 just because there's less math involved. So let's substitute in that a. That means we have 2a plus t equals 25. I'm going to substitute in the number 10 for a. 2 times 10 plus t equals 25. That means 20 plus t equals 25. T equals 25 minus 20. T equals 5. Okay, so here's my value for t. Here's my value for a. Now, it does say here it's a good idea when we check the solution to a problem to use the original problem, not the equations. So just to switch it up a little, we're going to use those two and see if they fit. So for equation number 1, if we have 10 admission tickets and they're $5 each, that's going to give us $50. If we have 5 train tickets and they're $3 each, that's going to give us $15. So that's $65 total. That works for equation 1 if you go back up. Yep. Okay, let's try equation 2. We had, if we have 10 admission tickets times, 10 admission times $2, that is 20. And if we had 5 train times 1, that gives us 5. Okay, so we have $25 total. Perfect. So, oh, sorry, I kind of rearranged those. Okay, so in the end, oh, sorry about that, guys. Ignore the dollars here. It should be the other way around. We had 5 tickets for $10, and we had 3 tickets for $5. And again, sorry, put the dollar signs in the wrong place. We had 2 tickets here for $10 and 1 ticket for $5. So the prices of the tickets, admission tickets, are equal to $10, and our train tickets are equal to $5. That is our solution to the question. So there's another check on the next page. Let's work through that one together. You can pause the video right now and try the check on your own. Again, that check is on page 403. So you can pause the video, try that one on your own. I'm going to go through the solution for this. So they have a math test. It has short answer and word problems. So the short answer question is worth 2 marks. The word problem is worth 4 marks. So I'm going to call these S and W to keep it simple. S for short answer, W for word. It tells us that there's 11 questions total. So if we add the short answer and word problem, we should get 11. And the number of marks for each, well, the short answer are worth 2. The word are worth 4. And it says that there should be 30 marks total. So from our chart, we can come up with 2 systems of linear equations. We have S plus W equals 11 and 2S plus 4W equals 30. So I'm just going to rewrite these here. S plus W equals 11 and 2S plus 4W equals 30. Now they've asked us to solve this problem, so they want to know how many short answer questions and how many word problems we have. Now you'll notice in equation 1 that both S and W have a coefficient of 1. So you can rearrange however you like here. They suggest let's solve for W, but again, your choice. So we'll solve for W. W equals negative S plus 11, right? Because we're moving that S to the other side. Or if you like it better, you can write it as W equals 11 minus S. They mean the same thing, okay? So you can write it however you like. Maybe I'll write it the second way here. 11 minus S. So let's substitute now W equals 11 minus S into equation number 2. So wherever you see a W, we're going to put this instead. So 2S plus 4 times 11 minus S equals 30. Distributive property, remember that goes to both of these. 2S plus 44 minus 4S equals 30. So we'll combine our like terms. We have negative 2S equals, the 44 is going to go to the other side, 30 minus 44. Negative 2S equals negative 14. Divide both sides by 2 to isolate S, and S equals 7. Now that we know that S equals 7, we're going to substitute that into equation 1 to find the value of W. So that means 7 plus W equals 11. W equals 11 minus 7. W equals 4. So our values are S equals 7, W equals 4. Let's see if that works with the word problem we had. So if we have 7 short answer and 11 word problems, that equals, 7 and 4. If we have 7 and 4, that equals 11. The short answers were worth 2. 2 times 7 is 14. The word problems are worth 4. 4 times 4 is 16. Add those up, we get 30. And that worked with our original numbers if you look up above in the question. So that means that there are 7 short answer and 4 word problems. So that's it for today's lesson. I would like you to do the practice on page 404 all the way to page 406. Use the answer keys on the Google Classroom to check your own answers, and we will be building onto this next week. Have a great rest of your day.